AI is clearly a hot topic. It's dynamic. It's top of the news, top of mind for sustainability professionals and industries across the globe. As you can see, the question that comes up is, where do we start? The opening box for ChatGPT, the latest version, comes up with, what can I help with? And ask anything. In Google's Gemini, it's where should we start is the question. And that blank space, that blank slate is an open call for any sort of possibilities, but that can be very daunting. And I think that's where we want to cover today is how do you dig in? How do you begin to look at those and try to harness those AI capabilities as they continue to evolve? So that's what we're going to cover today. And I'll give you a little bit of background about that. The landscape that we see right now from AI perspective is there are so many tools and options out there. You hear about them from all kinds of different sources, from the news, from YouTube, from articles, from LinkedIn, and that creates a lot of noise in terms of a lot of different options and what do they mean and how do they come together. It also creates interest because some of those themes, some of the problems that AI is trying to solve may directly be related to your challenges, but also some confusion. Which is the best one? How do we think about it? What are the opportunities we should be trying to leverage? You'll see, of course, there are full service platforms like Salesforce, like Oracle, that are integrating AI in a more comprehensive way. Those can be very expensive and also have a high engagement because they touch all aspects of your business. You could also think of it this what we might call the self-service options, which is going in directly as a user from a company perspective to engage with AI and the different models that are there. Those are low cost and provide more tactical support. And that's actually what we're going to be covering today. It's not how to implement the big program, but how to get started. But you need to consider the strengths and weaknesses of AI, meaning what are the things it can be good at, or if it has some different areas that are challenging, how do you build guardrails around those? And you'll hear a couple of examples. And then there's a whole ecosystem, a whole network of connected applications and tools around any given AI model. So if it's ChatGPT or if it's Gemini or Claude, there's a whole, um, as I said, ecosystem around those that you also need to consider in terms of implementing. Now, where to start, and this will go into a number of different ways to think about this, but typically we would see that you'd want to start with an initial strategy and some potential use cases. And this doesn't have to be heavy in terms of creating a big corporate policy, although you could certainly do that. But it could just be a call to action. How are we going to use this? Let's think through one or two areas where we want to experiment. It doesn't have to be the perfect fit. It's just something to get started. I think one of the things that we see is you can consider AI both as a technical resource to get something done and get something done faster, maybe in better or more complete or more scalable, or as an advisor. Ask it questions and ask for its advice and input on more complicated topics. Now, oftentimes, as you saw in those prior boxes to begin the conversation with an AI partner, we would say, think about your first request to AI being, how can you help me with this task? Instead of trying to figure it out and define it in an old school way of what are we trying to accomplish and how are we going to do it, and then engage with AI. Instead, ask it that question. How can you help me with developing this particular set of materials or analyzing this report or thinking about the strategy or developing some calculational methodology? Then you can use AI tactically in different ways to get some work done, but also then to understand its capabilities in a more concrete way rather than just sort of generically. And then, of course, with these, you want to test the outputs and evaluate them for reasonableness so that it's not something that you just take verbatim because that's part of that learning process and developing an understanding of what the capabilities and the weaknesses are. Then, once that platform is established of understanding and some trust of how to use AI, then you can begin to expand the usage and consider automation or maybe some of these more involved platforms rather than just diving in off the deep end and trying to make it all work from the beginning, where that can be a real challenge. Now, we might say, for instance, there's no easy button. And so the key is you just can't tell AI, fix this one problem and have it done, but you can accelerate it. It's more like a gas pedal. You can make things move faster and move ahead more quickly as long as you stay within those guardrails. Now, some of the trends before we get into two examples. as I'm sure you all recognize, the technology is evolving very, very quickly. Lots of changes, lots of improvements underway, lots of expansion of capabilities or interconnected applications or new features like be able to create video or audio or notes or integration with other tools you may already use. That's a great thing because if you come back to the same problem that maybe you couldn't solve 6 months ago, you may be able to solve it again today with the latest version because they continue to iterate on the capabilities. So it's great to see that expansion and some of those things that you had thought weren't solvable with AI. Wait another 6 months to a year, and they may be. This is a challenge though because the things that you may have already done, things you may have already embedded into a process, when the AI evolves, it can then break something that worked before or change the way that those outputs work. And that's an issue, just like you might have with an update to Excel, for instance, or an update to Microsoft Windows or its equivalent. You have everything locked in, everything's working great, and then you click that download, and all of a sudden the things that were working before don't work anymore, and you have to fix that. So it's very similar, and so you can embed the AI into a process and then have a change that you don't expect, and so that's why ongoing marketing is important. Also, there are lots of targeted applications, so small language models instead of large language models and really tactical ways to apply AI are coming out constantly as well that might compete with some of the more broad-based models that you have seen and that we will talk about. We see one internal usage pathway is that curiousness and curiosity about what it is and the discussions, and probably many of you have already tried to use AI in some way on your own, either personally or maybe to dip your toe in the water, but then really creating some structure on that, creating some test cases, some use cases to see can it actually deliver on a real result. And then once that's developed, ways to scale that up, ways to maybe automate or standardize or share a set model that you are creating for your own use. And then ultimately, you will begin to see once that's successful and you embed it, is the AI as almost like a team member that can specialize in a certain area. So maybe from a marketing perspective or research perspective or analyst perspective, something that you can then deploy in a way that gets more done as an augmentation of your existing team. Then finally, at that point, continue to scale up into bigger and bigger and more important areas of your business. Now, with that as the background, I'm super excited to turn it over to Somerset, who is leading a lot of our efforts for AI work in our own products and services. And so we're going to look at two real world examples where AI can be leveraged. One is employee commute data. We tend to run into this often. If you have thousands of employees or even hundreds of employees, understanding how they commute, the impact from that can be challenging. There's a lot of data, a lot of gaps in the data, a lot of things that in the past would cost money and time to generate the input that you need and may not be complete. And then the other is regulatory intelligence. So regulations come and they expand and they're different in different markets and they're not typically understood by the broad array of all the stakeholders within your organization in terms of what impact it might have. And so that's the one that's a little bit more interpretive. And so these are two examples that we've chosen to share that we can dive in more detail. So with that, I'll turn it over to Somerset. Thanks.
Perfect. Thank you, Ben. Okay, so let's start with a practical example. We look at scope 3, category 7, employee commuting issues. So on paper, this category looks simple. Calculate commuting distance, apply emission factors, and report annual emissions. In reality, the challenge isn't the maths, it's the data. To calculate commuting emissions properly, we need average distances and modal splits. That means postcode level inputs, office days per week, and transport assumptions. But that information is often sensitive, fragmented across HR systems, or inconsistent between sites. On the right, you can see commuter modal splits comparing the UK and the United States. In the UK, we can see that while single occupancy car travel dominates it, rail, bus, and walking is still meaningful. In the US, single occupancy car use is significantly higher and structurally dominant. So why does this all matter? Because geography drives emissions intensity before you even calculate anything. A US heavy workforce will typically have higher commuting emissions than a UK based workforce, unless hybrid policies are strong. So already we see that assumptions, these are location, modal split, hybrid working, are materially shaping the result. So what does AI do for us? Artificial intelligence offers a range of useful capabilities in this context. Firstly, geospatial analysis. AI can process geospatial data to accurately estimate distances between locations. This is essential for understanding travel patterns and logistics. Secondly, research and reasoning. It can automate the development of commute mode breakdowns and calculate emissions factors, helping to streamline environmental assessments and reports. Thirdly, scalability. AI tools can scale this across multiple sites simultaneously, helping to save time and ensure consistency throughout outputs. So once we understand the challenge, the next step is structuring the calculation properly. So how do we move from rough estimation to something structured and defensible? We start with controlled inputs. We use employee postcodes only, using no personal identifiers, along with office days per week and modal split assumptions. For example, we could use DEFRA conversion factors to apply them, including archived years, to ensure consistency over time. Now let's briefly walk through how the system would work. Firstly, we would clean and define the boundary. AI ensures that postcodes are standardized, missing or invalid entries flagged, and the scope is clearly defined. Secondly, distance and annualization. AI would then calculate one-way kilometers, multiply by 2 for return journeys, and then annualize based on office days per year. Hybrid assumptions are parameterized, meaning they're transparent and adjustable. Thirdly, for emissions factor mapping, each mode would map directly to the correct data factor for that reporting year, with units controls built in. Finally, documentation and review. AI produces method notes, assumption logs, and quality statements that are generated. A human review happens before the outputs are finalized. Importantly, the automation reduces friction and the governance ensures credibility. And once that structure is embedded, we can evolve the workflow further. The key lesson from this example is that the bottleneck is within the data structure and coverage, not the calculation. AI is particularly strong in standardization, anomaly detection, and documentation, but assurance readiness depends on version control and lineage. If you change emission factors libraries or validation logic or even prompts, the output will definitely change. These changes must be logged. The goal isn't just faster reporting, it's repeatable, defensible reporting. In the illustration shown on the slide, we can see that total category 7 emissions are around 8.6 tons of carbon dioxide equivalent. Average employees emissions coming in at 0.17 tons. And the example shows a 14% year-on-year reduction. That reduction might come from hybrid policies, modal shifts, or operational changes, but the system makes the driver transparent and traceable. And that's the key shift, moving from estimation to structured reporting. So now let's apply the same system thinking to a different sustainability challenge. So here we move from a structured model to an advanced system-led operating model. We standardize inputs and logic across years, entities, and geographies. Reusable templates help to reduce errors, ensuring the headers are maintained. Controlled versioned factor libraries prevent silent updates. Business rules help to change and ensure that boundary adjustments are logged. These are more efficient, with a 60 to 80% reduction in prep time once embedded, more consistent, helping to control updates with fewer discrepancies, and also more scalable, helping to work across multiple sites within the Scope 3 categories. They also offer lower risk, with fewer unit or factor errors and reduced manual overrides. So the outputs are defined. A dashboard with clear totals, intensity metrics, trend analysis, transport mode breakdowns as well. Executive narrative. The AI can produce a 1 to 2 page summary highlighting all of the key information points. And with the logic model, there's a clear separation between inputs and the calculation engine. So how does this actually help us? So we've learned now that it helps us to automate the admin, not judgment, process design matters, document boundaries and assumptions, as well as data sources. Advisory value now moves upstream. So with that advanced workflow in mind, let's move to regulatory intelligence. Regulatory updates are often an issue as they're high volume and fragmented across jurisdictions, whether this be the United Kingdom, the EU, or further afield. Teams often lose time finding, interpreting, and prioritizing updates, and the decisions aren't always traceable or accessible dependent on your level of understanding. The risk isn't just missing updates, it's misinterpreting the scope, deadlines, and obligations, all under time pressure. The AI approach can help to monitor authoritative sources using AI to summarize changes, extract obligations, tag deadlines, and even classify risks. AI can also apply a consistent rubric and require citations and uncertainty flags, helping for further documentation down the line. Treat AI outputs as an unbiased draft intelligence layer. However, this means that it does require further human verification and checking over within the first stages. So what does that structured intelligence architecture look like? This slide shows the architecture clearly. For source ingestion, we use relevant official regulator websites, government publications, EU and UK portals, as well as verified briefing and secondary sources. For AI processing, we can add our needs and rules, helping to summarize updates, extract relevant obligations, identify deadlines, classify risk, and flag uncertainty. In terms of the output, we receive a structured output, whether this be a weekly digest, a daily digest, an obligations tracker, action log, government documentation, and so much more. Instead of reactive monitoring, we are now at a level of repeatable intelligence cycle, all while saving time and maintaining compliance. Integrated reporting. So if we look at regulatory digest and obligation trackers, these are some of the outputs that we can see. We get a systematic approach with a clear scope and defined sources. And we've learned that speed matters. Faster interpretation creates a strategic advantage, all while maintaining quality. Governance safeguards, so strong oversight helps provide over-reliance on automation, all while maintaining a quality result. Across both examples, the pattern is consistent. AI helps to reduce friction. Structure improves consistency, while humans retain judgment. And the value shifts from calculation to system design. So if we look through a more advanced example, this is a custom ChatGPT model within the ChatGPT app. And we can see here, there's a variety of different fields that we have to fill out. One of them, the main one, is the core instruction prompt. So for this example, this would be to monitor, summarize, extract obligations, help to tag deadlines, classify risk, all while citing the sources. So through creating a custom GPT, we can flag uncertainty and remove guessing. We're essentially giving the ChatGPT guardrails and certain rules that it has to follow. These rules might be sector relevance, risk rubric, output templates, and so much more. So what do we have to give it? We want to make sure that we're extracting relevant deadlines for a relevant scope from cited sources that are authoritative and verified. In terms of knowledge, we can also add regime summaries, sector and entity mapping, risk rubric, tracker headers, as well as templates for it to fill. So what does this look like? In terms of governance, we have access to controls and output logging for QA. We can set it on a weekly loop or a daily loop to run for us. This helps to ingest new items. The ChatGPT then processes this and outputs it in our desired format. This can also mean that we can approve wording, assign owners, and record decisions, helping to create a linear time frame. In terms of QA, there should be random sampling to compare outputs to sources and help to fine-tune the prompt for a faster and better result. And that leads directly to the integrated outcomes. So that brings us to the end of the examples. We've looked at two very different use cases, scope 3 emissions and regulatory intelligence, but the underlying architecture is the same. Structured inputs, AI as a processing layer, governed outputs, and human oversight.